Hello student, let's try to understand top 50 problems on the Grignard reagents react with aldehyde and ketones. So that things we are going to understand student. So first of all, let us try to understand the first one student. First one, that is Grignard reagent with the formaldehyde. We are treating Grignard reagent with the formaldehyde and trying to find out what is the product student. So since reaction takes place in two steps student, that is in the first step what happen, adduct form with the Grignard reagent, and then in the next step on acidic hydrolysis it gives the product student alcohol. So here you see student, suppose it is having the RMgX student and you are treating with the H C double bond O and H student. So what will happen, you got to know student, this is the electronegative student. So this electronegative, this is the positive, this is negative, this is going to attack on this position student. So this is shifting here and as a result this will take this magnesium ion. So this is going to form the adduct student. How the adduct will be forming student, here is HCH, downside it will be what student, that is the R, here is O MgX. Now student, this is what is called student adduct. What is going to happen with the adduct student, you are going to do acidic hydrolysis student, okay, HOH you are taking. So what going to happen student, this MgOHX is going to be out student, okay. So here is MgOH and X is out. So what is left here student, dear student, this is the R, then it will be CH2 and here is OH. So it is giving with the formaldehyde, it is going to give 1 degree alcohol student, 1 degree alcohol. Now let us go with the second problem. What is the second problem? If you are having CH3 and you are treating with the CH3MgBr, right, and you are again treating with the formaldehyde. What is the formaldehyde? HC double bond O and H student. So this is how the alkyl group is going to attack here. So this bond is shifting here, as a result this will take this magnesium ion. So what is going to happen student, what is going to happen, this is forming the, going to form the adduct. So it is the adduct, how the adduct will form, see downside CH3 group is going to be at CH3, here is C is there student and these two hydrogen are there. So here is I am writing CH2 and this will be OMgBr student, this is what is called student adduct. Now what will happen to adduct, we are going to do the acidic hydrolysis HOH, okay. So this will similar way, what will happen student, this is the MgOH and Br will be out student, and what the next product you can see CH3, this is CH2 and this will be the OH. So student, this is the 1 degree alcohol, again you are going to get 1 degree alcohol, right. Now suppose the another reaction student, you see the third one we are going, if we are having phenyl magnesium bromide student, phenyl magnesium bromide. What is the phenyl magnesium bromide? This is what phenyl group student, okay, this is the Mg and this is Br student, and now you are sitting with the formaldehyde. So dear student, what will happen, this total is going to attack on this position. As a result this bond is shifting here and this will attract this magnesium ion. So what is happening here, so you will find that the phenyl group will be in the bottom and then it will be the this position CH2, this is CH2 and O Mg and Br, right student, this is what is called adduct, friend, this is the adduct. Now this adduct on hydrolysis student, acidic hydrolysis you are sending. So what it is going to happen here, MgOH is going to be out, MgOH Br, MgOH and Br, and what is left student, benzylic alcohol, and you know benzylic alcohol is 1 degree alcohol. So this is the 1 degree alcohol, right. Now let us move on the fourth question student. Fourth question, suppose at the place of, here you can take CH3 CH2 MgBr, right, and you are treating with the formaldehyde HC double bond O and this is H. So what is going to happen, this total alkyl group is attacking here, right. this way. So this bond is shifting here. As a result, O will become negative and it will attack on magnesium ion. Magnesium is positive, this is negative, this is negative. So what is there going to be, student? It will be the adduct CH3, then it is CH2. This CH2 is going to be joined with the again CH2 and here OMgBr, right student? Now student, what is happening here? This is the adduct, this is called the adduct, right? Now you just send it the acidic hydrolysis, student, HOH, right? So MgOHBr is going to be out, student. This is, so here is MgOH and here is Br. What is the left one? What is the alcohol you see, student? It is CH3, this is CH2, CH2OH. So that is what is propane 1 all, student. It is going to form propane 1 all. Now let us move on the fifth one, student. Fifth, if you are going fifth one, let us take the acetaldehyde. Okay, so suppose you are having RMgX and you are taking the CH3, C double bond O and H. So what is there, student? This alkyl group is negative, so it is going to attack here. It will be the negative charge because it is the positive, negative, positive. Now this oxygen will take the magnesium ion, so it will form the adduct. Now R is going to be joined from the bottom. So R, here is CH3, student, then it is the C, here is H, this is OMgBr, right student? This is what is called, dear student, adduct. This is adduct. Now you send with the acidic hydrolysis, student, this is HOH. So what will happen? This MgOHBr is going to be out here. So it is Mg, this is OH and here is Br. What is left? Here is R, then it will be there, student, C, O, here is this hydrogen will go, this hydrogen is going to be on this position. So this become the OH and this side is CH3 and hydrogen is this hydrogen is as it is. So this is the 2 degree alcohol, student. This is what 2 degree alcohol. So with the acetaldehyde ethanol, student, it will going to give 2 degree alcohol. Let us see CH3, Mg and Br, student. This is the positive, negative, negative. If you are treating with the acetaldehyde CH3, C double bond O and here is H, you know this is partial positive and partial negative. So how the attack will be there? This methyl group will attack here, this bond will be shifting here. Now this will attract the magnesium ion, so it is going to give adduct. So CH3 is attacking from the bottom, so CH3 is here, then C, this side H, here is the CH3, student, and here is OMgBr. Friend, this is the adduct. What you are going to do? You are acidic hydrolysis, you are sending it HOH. So what will happen? MgOHBr will be out, student. So this is what, that is MgOH and Br is there. Now what is left here? This is CH3, this is CH, this is CH3 and the upside, that is OH. This hydrogen is gone what position? This position, student, with the O. So it become OH, this CH is this neutralized, shifted to this carbon. So now this is the 2 degree alcohol, student, 2 degree alcohol. Now let us see, if you are taking next example, student, this was the example number 6. This is the 6. Now we are going for the 7 number. Let us see. If you are having CH3, CH2, MgBr, student, MgBr, and you are treating with the CH3, CH2, C double bond O and H. Friend, what is this one? This is partial positive. You got to know carbon, partial negative. This is negative, this is positive, this is negative. So total this methyl group is going to attack on this position. So it will be like that. So this oxygen will be taking a magnesium ion. Okay. So if this will take the magnesium ion, student, here, so what it is going to form? It is going to form adduct. So CH3, CH2, it is attacking from the bottom. So CH3, this is the CH2, this carbon they attack C, here is H, this side what is there, student? This carbon CH2 and CH3, and what is the top? Here is O, This is the Mg and Br student. Now friend, what will be happening here? Okay, let us see student. Now do the hydrolysis student. HOH in presence of few drop of acid. So here MgOH Br is out, and this hydrogen will take the position of this one. So let us see student how the product will be there. CH3, CH2, CH, and here will be what student? OH. This is CH2 and CH3 plus what is there? Mg, OH, and here is Br. This is what student? 2 degree alcohol. 2 degree alcohol. So this is what we got. Now let us move out the example number 8 student. If you are talking example number 8, we are taking the ketones. Okay, so R we are having MgX, and plus you are taking student R, C double bond O and R student. You got to know this is negative, this is electropositive, so this is negative, this is positive, this is negative. So here is the R group is attacking here, this bond is shifting here, so this will attract the magnesium ion. So it is going to give what student? Adduct. So how the adduct? One R is getting added from the bottom. Here is C, this is R, this is R, here is what student? OMGX. Now this is the adduct student. With this adduct we are doing the hydrolysis, HOH in the presence of a small amount of acid. So what is there student? MgOHX is out. Here is MgOH and this is the X. What is left here student? R, C, here is OH, this is the R, here is the R. So this is what student? 3 degree alcohol. So with the ketone it is going to give student 3 degree alcohol. Right, now we are going for the question number 9. Let us see the example number 9 student. Suppose we are having CH3, Mg and Br student, and you are treating with the CH3 acetone student. We have taken simply the acetone. So partial negative, partial positive, this is negative, this is positive, this is negative. So this bond is going to attack here CH3 group, this will shift here. Now this oxygen will attract the magnesium ion. So what is happening dear student? CH3 is going to add from the bottom CH3, then here is C, both side of the carbon is there is CH3 group, this will be O and it is adding with the MgBr. Now this is the adduct student, right? Now you are going to do the acidic hydrolysis student. So what you are happening? MgOH Br will be out student. This is what? Mg, here is OH and that is Br. Now student, what is left here? You please see this one, the product, final product C. Here is the OH. Now this is CH3 and bottom is also CH3. So what is degree student? 3 degree alcohol. This is the 3 degree alcohol. So with the what is student? Acetone, it is going to give 3 degree alcohol. Now let us move on the question number 10 student. Okay, so if you talk about the question number 10, let me check that is what problem we can, most probable problem which we can give student. Now suppose we are having little bit tougher problem. I am taking CH3, CH2, Mg and Br is there student, right? And you are treating with this one, double bond O. This is the ketone student. So it should give the 3 degree alcohol. How the reaction will takes place? This is negative, this is positive, negative, positive, negative. So student, this bond is going to attack on this position. As a result, this is splitting out, so it will take the magnesium. So here you see dear student what is happening here. Very simple, you have to be very careful. O MgBr student, with this position what? CH2 and CH3 is there. Now treat with this is the adduct student. Just you do the hydrolysis student, acidic hydrolysis. What will happen? MgOH Br is out student. Here is, so this is MgOH and Br. What is left here student? What is the product? Final product. Final product is this one student. This is OH. Here is CH2 and CH3. So what is the degree, if I will ask you what is the degree of this alcohol, student? Alpha carbon, this is the alpha carbon attached with the 3 carbon, so 3 degree alcohol, it is forming the 3 degree alcohol. So if you are treating with the ketone, always the product will be the 3 degree alcohol, student. Now let us move on the question number 11, student. Let us see the question number 11. So what is the 11 number? Suppose this is the compound, student. Here is the C double bond O, here is the H, student. Now they are saying you just treat this compound, student, with Grignard reagent. What is the Grignard reagent here, student? This is the benzene magnesium bromide. Okay, so if I will see, student, this is the this benzene ring is going to attack, student, on what position? This one. This bond is shifting here, so this will attack. So now see the what is the intermediate which you are going to accept, student. So this is the group, here is the C is there, this OMgBr, student. Now here is the hydrogen is also there, this will be the benzene ring, friend, right? This is a benzene ring. Let us see, student, after this benzene ring what will happening, just you do the hydrolysis because it is the adduct unstable. So HOH, friend, in the presence of H plus ion, so MgOH Br will be out, student. So here is the MgOH and Br, student. Now let us see the product, student. Here this one, here is what is there, CH, this is what is the OH, and here is the what, student, this is the alcohol. So what is the degree of alcohol, student? Since it is aldehyde, so it will be the 2 degree alcohol, student. It is nothing but 2 degree alcohol, right? Now let us move and find out some other examples, student, which we can understand. This is the example number, we are going to example number 12. Students, what the problem we are taking here, let us see the benzaldehyde I have taken. So C double bond O, here is the H, student. Now you are treating with the what? CH3 MgBr, student, right? This is the CH3 MgBr. Student, what you are going to do, friend, this is the negative, positive, negative, this is the positive, this is negative. So this alkyl group is going to attack here, this bond is shifting here, this will take this one. So what is the product, friend? What is the product here? Adduct will be forming, student. This is benzene, here is what, C, right, student? Here is OMgBr, student, OMgBr. Now friend, downside it is the CH3, friend, and here is the H. Now you are going to do a, student, HOH, here is the H plus, student, right? Dear student, it is the MgOH-Br, student, it is going to be. So here is MgOH and here is Br plus what is the our real product, student? Since it is aldehyde, so it should go, alcohol should be, that is 2 degree alcohol. This is OH, here is H, this is CH3. So this, the degree of alcohol is 2 degree alcohol. So you see, other than the methanol, student, all aldehydes are what? Give the 2 degree alcohol. Let us do the ketone, student. This is the acetophenone. This question will be number 13, student, 13 number. Suppose this is what? C double bond O, here is CH3. Now what we are going to do, student, we are taking the Grignard reagent. You can take the CH3, this is the Mg, and here is Br. So let us see, this is the negative, positive, negative. This bond is shifting here, so this will attract magnesium ion. So what the adduct you are going to receive here is, student, this is the benzene ring, here is C, this is the what? OMgBr, right, student? Here is the CH3, right, student? And here is what will be there, student? Already CH3 is there. This is what is the adduct, friend. Now you just do the acidic hydrolysis and see the product. So acidic hydrolysis HOH friend. So what will be there student? MgOH Br. This is friend here. You see. This is the MgOH and Br. So this is what is the ketone will give always 3 degree alpha carbon attached with 3 carbon, so 3 degree alcohol student, right? Now let me check if any other possibilities are there student. There are many more possibilities student, but we are not going all the way to solve this one. Suppose we are having the one aldehyde we are taking student, and this is the problem will be problem number 14. So in case of problem number 14 student, here is CH3 CH2, this is CH2, and here is C double bond O and H, this is aldehyde. Now student, here is the benzene ring is there student, this is Mg and Br. So student, what will happen, this completely it is going to attack on this carbon student. Which carbon? Carbonyl carbon. So it is attacking here, this bond is shifting here, so this will attract here. So it will give the adduct. Let me check what is the adduct. CH3 CH2 CH2 C OMgBr student, OMgBr. Here is the hydrogen, this is the benzene ring student, right? Now you do the hydrolysis student, HOH, okay, acidic hydrolysis friend. So what is there student? MgOH-Br student, right? Here is MgOH and Br. So what is the product here dear student? CH3 CH2 CH, here will be OH student. Little wait. CH3 CH2 CH2, here is CH, this is OH, this is. So what is the degree of alcohol student? This is going to be 2 degree alcohol student, right? The Grignard reagent also gives the product with the carbonyl, okay student, carbonyl chloride, okay, that is acid chloride, esters, and this all that we will make the another video student, that we are not considering this one in this video, particular video. So I hope this will be helpful to you to understand student. Thank you very much for watching student.